Okay, for the next item we have regarding network analysis. Okay, let's say we have as a case, we have water to be flowing through a network of pipes as shown in the figure below. And let's say that we have for the flow rates, okay, we have f of 1 is equal to 800 and f of 2 is equal to 200. And if the system has an infinite number of solutions, we can express what we have in parametric terms. Okay, so we have in the diagram, okay, and what I can do is that I can just label junctures, and so just sort of zooming in. Okay, so we got in the layout. Okay, so I have one, second juncture, third juncture. And you can put these in most any order. And let's say that for what we have in the case of, again, just for the network, okay, what you have going in will be the same as what is going out. And we'll say we have at juncture 1, okay, so you have f of 1 going in, and what is going out, we have x of 1 and x of 3. And letting f of 1 be equal to 800, you see we have 800 is equal to x of 1 plus x of 3. And say that in the case of the second juncture, you have going in, you have x of 1, and going out, we have x of 2 and x of 4. And say for what we have in the case of the third juncture, okay, so you have x of 2 going in, and going out we have x of 5 plus f of 2, and again we have f of 2 equal to 200. So at the moment we can say we have x of 2 is equal to x of 5 plus 200. And for what we have in the case of the fourth juncture, okay, so you have going in, you have f of 2, and going out, you have x of 5 as well as x of 7. Again, we have f of 2 at 200. And for what we have in the case of the fifth juncture, okay, so you have going in, you have x of 7 as well as x of 4. And exiting, we have x of 6. And for the last labeled juncture, we have going in, we have x of 3 and x of 6. And exiting, we have f of 1. Again, f of 1 is equal to 800. Okay, so we have out of the juncture, so just setting up our system of equation. Okay, so we got for the first, okay, so you have x of 1 plus x of 3 is equal to 800. Next, okay, we can say we have x of 1 minus x of 2 minus x of 4 is equal to 0. And from the third, we can say that we have x of 2 minus x of 5 is equal to 200. Then we have next, we can say we have x of 5 plus x of 7 is equal to 200. And we have for the fifth, okay, we have x of 4, You can see we have minus x of 6 plus x of 7 is equal to 0. And we have, for the last, okay, we have x of 3 plus x of 6 minus 800 is equal to 0. Okay, so setting up what we have in terms of a matrix. Okay, so I have x of 1 plus x of 3 equal to 800. And so I have the subscripted values from 1 to 7. So we have 1x of 1, no x of 2, 1x of 3, and then no x of 4, 5, 6, or 7. Again, have is equal to 800. Next equation, I have 1x of 1 minus x of 2, no x of 3, got minus x of 4, again we have is equal to 0. Third equation, I have 1x of 2 minus x of 5, again I have is equal to 200. We have x of 5 plus x of 7. That is equal to 200. Then we have x of 4 minus x of 6 plus x of 7 is equal to 0. And then we have x of 3 plus x of 6, and you can rewrite this, okay, whereupon we have x of 3 plus x of 6. I don't know why I moved the 800 over. We have x of 3 plus x of 6 is equal to 800. We're just kind of taking what we have for visual purposes. And we have in terms of the reduced row echelon form. Now for equations of systems and looking at what we have from the information in terms of translating what we have among our variable terms. And so we got for the system, okay, so we have 1x of 1, and you have it's going to be equal to, so you got 2, 3, 4, 5, 6. X of 1 is equal to x of 6. Next row we have x of 2, and that's going to be equal to 200. And we have for x of 3 is going to be equal to 800 minus x of 6. And we have for x of 4, okay, and that's going to be equal to negative 200 plus x of 6. And we have next in line, okay, so we have x of 5 is equal to 0. And we have, okay, if you notice, we don't have, again, we have x of 1, x of 2, x of 3, x of 4, x of 5. Okay, but we don't have an x of 6. So x of 6 is one of those free variable terms. And we have finally have x of 7 is equal to 200. Okay, so for what is going to happen in this case, so we have x of 6, okay, that is the only free variable. So we have the x of 6 is equal to t. And just looking at what we have, so again we have x of 7 is equal to 200. X of 6 is equal to t. X of 5 is negligible. X of 4, we have negative 200 plus x of 6, so that will be negative 200 plus t. And x of 3, you have 800 minus x of 6, so we have that x of 3 is equal to 800 minus t. And we have that x of 2 is equal to 200, and we have x of 1 is equal to x of 6. And so we're going to have that x of 1 is equal to t. So that would be the set of results here. So there was only one free variable, and so we had only the letter t necessary.